So here we're actually going to implement the multiple regression model. And we're going to run a multiple regression model on a few variables that could be useful to predict walking distance. And this is how you write them on the in R. Note that the first one is the outcome variable, and then there's a tilde, and then the other variables here. And you could have a space to read better. That wouldn't be problematic, but you don't have to. So the predictor variables are a long function, age, gender. Notice how I'm using this function for gender, just in case gender wasn't categorized. And I also have one for COPD severity. So COPD severity is a categorical variable, so we want to make sure we tell the model that, because it is listed as 0, 1, 2, 3, 4, so that the computer may think that it's an integer. So we want to make sure that it's considered as categorical for the purposes of this model. And then comma, and then the parameter, data parameter, which is our COPD data variable here. And you can run the model first. It goes into this variable here that we just named whatever we want to name. And notice also that I've mentioned this before, the equal sign, often you see this notation in R, but I just prefer the equal sign because it's less work. Just some people get confused because the equal sign, I can do different things as well. But if we run the linear model, loads it into this variable, and then we get the summary. I'm going to run these two together, and then you get the results of the multiple regression model. So there are the main results over here, the intercept. And let's take a look at FEV1. FEV1 is 30. So it went down from before. It was about 74.11. But now notice how it became not significant. Age is significant. And at the 0.01% level, it's below 0.01, the p-value. The estimate itself is negative. So that means that the more the age, the less the walking distance, which makes sense. An unit increase in age leads to a decrease in walking distance by negative 3.5. Of course, on average, and then you can check the confidence intervals as well. Gender here is not significant. I think that's what we saw before as well. And COPD severity, remember how to interpret these categorical variables. They're always in reference to one reference level that is left out. So this is the impact of COPD severity being moderate in comparison to COPD severity being mild. And it's a negative association, but it's also not significant. Only very severe is significant, meaning if a person is very severe compared to the people who are mild, they will have a decrease in walking distance by this amount, and that's a significant result. And this model actually got a little bit better. So multiple R squared 29 or adjusted R squared 24, about 25%. So now the model explains 25% of the total variation in the walking distance variable that we're using. So it's actually not terrible for a multiple regression model. We want R squares at least this much, and sometimes R squared too high, like let's say 80%, it could be this faulty calculations going on there. Now, how about we can also use here a confidence interval for the whole model itself. And is this kind of just chilling there? Yeah, okay. And you can see the confidence interval for those estimates that we had, because this is the general, right? This is the middle, but if you want to be 95% confident, even more confident, then you can refer to these numbers over here. Now, this model wasn't great. There's a lot of stuff here that was not significant. This variable that we thought was significant became not significant when we considered and included other variables in the model, which means that we're also controlling for these other variables, which is a good thing. So let's build a different model. So we're going to add and remove some variables. We're going to remove the FEV1, And then we're going to add diabetes. Now, it wasn't clear if diabetes was correlated with COPD severity before, but now we're actually seeing if diabetes is correlated with walking distance. So if, by having diabetes, does that increase or decrease your walking distance? And this is listed as 1 or 0, which may be interpreted as integer. Let's make sure the computer interprets it as a factor. And then everything else stays the same. We're just removing FEV1 and adding the diabetes variable. We build the model, we load it into this variable here, just called multiple linear regression 2, and we got the summary, and let's run that. So we ran this multiple regression model, and notice how actually we have more significant results now. We have diabetes is a significant association with walking distance, and it's a -1, meaning that if you have diabetes compared to the people who don't have diabetes, there will be a decrease of 82, I guess, meters in walking. So in 82 points in walking, and that's a significant association. Age remains significant in this model. And notice how also COPD severity became now more significant, had some other significant values from the previous model. So in general, this is a better model because we have more significant predictors. And also, let's look at the R-squared, how the R-squared went up. So now we are about 37 or 34% of this that this model explains in walking distance, which is our main variable of interest. So we actually improved it considerably. And we also have other variables. So you can, depending on the data you have, you can check with other variables and examine other variables. So there's a smoking variable. Does smoking increase or decrease your walking distance? And let's run that from the console. It's okay. And you see that, well, in this model with the smoking, so what did I do? I actually just added smoking into the model. So I didn't remove any variables, and I added smoking. Smoking is also a factor variable. But notice that it's not significant, and it didn't really improve the R-squared. So it doesn't seem like useful to add this variable to the model. But I just wanted to introduce you these general ideas of multiple regression. I hope this is useful for you, and see you next time.